seen single variable linear regression last time. So this time, as we discussed, we'll be talking about multivariable in the sense we can have multiple variables x1, x2, x2, so on, so many. Even in case of example, what we have discussed in in the first session, where when we took an example of house rent prediction. So if you remember, uh, let me go there. So where we have taken three different variables, x1, x2, and x3. Let us say it's a BHK, demand and area, and we try to predict rent. So this is one example of a multivariable classification. So sorry, multivariable linear regression. So let's try how. Let's go behind the math of it. Okay. So
Raju, so
mhm.
even this multivariable or single variable, you need to fetch the data to the machine, and afterwards, based on this data, if you ask for any particular details, that will give a rough figure, right?
Yeah, exactly. If this is true with every machine learning example, what it will do is
Hmm.
actually we did not go into exact machine learning what will be the structure and all, but let's
Okay,
go to that point. So in case if
understood.
you
Okay, you are
provide,
just only yeah, you are only just covered the points how the data can be vary and what is the relationship between the two variables.
yeah,
That's what
how
you
to
cover.
what will be the math behind it? We are talking about that, but the
Yeah,
actual
yeah.
flow we'll be anyway discussing in further session. But let me give a short
Okay, fine.
overview on this. So you take a
Fine.
history data. From the history data, we'll be getting relation between x and y. Okay. So yeah, our model is actually learning what will be the relation between x and y depending on our history data. Means whatever data we are going to say. So from that it is going to give y. Okay. So for a new values now let's say we are going to give new data over there. So it knows this f of x, and from this now there won't be any more learning. So what it will do is it will do the prediction based on what it has learned already. Okay, so it will do the predicted one. Okay,
So
so
in general, the data what we have given with that, it will plot the scenario for this
Mhm,
particular x value, y value this much, and
mhm.
whatever the gaps in between is there. So based on the relationship between the points what we give, that gaps it will fill and it will fetch the data for us.
Yeah, gaps in the sense. Okay, let me. What it
See,
will do
let's
is.
take an example. 0, x value 0 you have, and 10
Mhm.
you have, 20 have.
Okay,
Correspondingly, y value you have 20, 40,
okay,
50. In
okay.
between, if you ask for a data 7, so based on this plot, whatever the relation is there, based on that, it will give a value for a x value of 7, corresponding y will be give. It will be
See,
given, right?
yeah. It will learn what is the relation between these two, right?
Exactly, exactly.
Right. So the relation is, let us say, f of x, okay, for simplicity, theta naught plus theta 1 into x, it will learn these two values. What will be these two parameters, right? In a
Correct.
straight line, if you say f mx plus c, if you know these two parameters, you can draw the line, right? So similarly, it will learn these two parameters here, and it will fix in a model. If you give x, you will be calculating theta naught plus theta 1 into x, and you'll be giving that as an output. Okay. So this is what it will do. In case for a new value, you give a new value 100. Okay. So let us say theta naught and theta 1 is 10 plus 20x. Okay. So what it will do, it will go inside. So 10 plus 20 into 100. So which will be 2000. You will be getting answer as 2010. Okay. This is
Understood.
how it will be done. Okay.
Yeah,
Yeah.
yeah.
Okay. Yeah. Let me erase this part. Anyway, we are going to talk about this in further session in much detail. Okay. Okay. So we are discussing about this, right? In case if you have multiple variables, let's say x1, x2, x2, so on, xn. So for that, again, how do you think our function will be a function of x1, x2, x2, so on, xn, right? So your output, what it can be like theta naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3, so on till theta n xn. Can we write it like this? Okay. So it's similar to the same example here. For a single variable, we wrote it like this. Similarly, for n variables, we wrote it like this. Okay. So for this, again, our output, like what will be the process will be similar, because like what we'll do, let me go to first this one. So once you define a structure here, then you also define a loss function. So loss function. So what will be the loss function here? It will be like RMS error, where you calculate y actual minus y predicted whole square under root divided by n. Okay, so this is what we are going to calculate. So in this, let me tell you something, like let me try to expand here first, then we'll also expand it for a single variable first, and then we also explain it for expand it for a multiple variable. Theta 1 x. Okay, so this is y predict. Okay, for a value, it will be, this will be a y predict, and actual value will be y actual minus y actual minus theta naught plus theta 1 x whole square sum root over n. We can write like this, right? Similarly, sorry, it will be minus like this. Similarly, even here it will be y actual minus theta naught plus theta 1 x1 plus theta 2 x2, so on, whole square and sum of under root by n, right? So just I try to expand and show you like how, in case you get y, right, so y prediction, you are calculating like this, and then you are subtracting from y actual, and then like making square of it, and then this. So okay, now you also know what will be the error function. Okay, it can be this or this, anything you think. So what will be the next step? You have to select what algorithm you are going to use. Let's use the same gradient descent. So what will be the gradient descent? Like theta equal to theta new equal to theta old. A small correction in what I have told yesterday. So if you remember what I have told about like gradient descent is, it is like I have told it as plus, right, but it will be minus. So let me do that correction. I thought I'll do it like in front of you. So this is a small correction. Uh, in case if we have taken some numerical example and do it, like we would have identified that time. Okay, this will be minus here. Okay, that is gradient descent. So let's go there. Use the same formula here. So minus dou E by theta O. Okay, it will be dou theta anyway. Okay, so this is what we are going to have as a gradient descent. From the gradient descent, it will start updating the value. We also have one more thing, which is alpha as a learning rate. Okay, we define this learning rate. From this, we are going to update the theta. What we'll be getting from this is new values of theta naught, theta 1, theta 2, so on, theta n. Okay. So this is what we are going to get. So if you see, the concept is same even for multivariable, right? Even let us say you may have a combination of x1, x2, right? So in the sense, something like, can you also, okay, you can also define your y as theta naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x1 x2, something like this, right? Plus theta 4 x1 square plus theta 5 x2 square, something. Can we write like this? This can also be possible, right? It need not be a linear, because thing is like, in case if you have values like this. Okay, so not just we can get a straight line, we can also get something like parameters for curve like this. Okay, so this way. Okay, for that what we can do is so for that kind of curve you can get it this way. If you can see, this is what if for like if you have a curve like this, right? X1 square actually will give you some curve like this. X2 square will also give some curve like this. So it will be addition of let me tell you something. So this is X1, let us say this is X2. Similarly X1 X2 is usually XY graph will be something like this, something like this. You have x1 square will be like this and x2 square will also be like this. So if you are adding this plus this plus this plus this, something like this, right? So, and we are finally getting some curve, which will be something like this. Okay. So this kind of complex curve as well, we will be able to read. Okay. Like we will be able to learn. Sorry. So through the same thing, okay, it won't be just linear value. We can even go for a higher order terms as well. So this we can call it as like polynomial regression. So where we are learning like higher order terms, and this is again based on our complexity, right? So in case your values are something like this. So this is almost straight line would be enough to draw draw a line, right? Like it can be connected through a line mostly. But in case if your values are something like this, okay, this is fine. So what about if it is this way? You if you draw a line, you may get like some error, but it can get minimized by using something like this. By using a higher order term, maybe you may get something like this, right? So that is one more thing. Then how are we going to define such thing here? So just the thing is, what we should be doing for a kind of calculation here, we only know like if it is in this format, right? So what we will be doing is, even for x1 square, let's take the same, write the same thing here as well. Okay, so y equal to theta naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x1 square plus theta 4 x2 square plus theta 5 x1 x2. Okay, you can even have x3 x1 cube x3 x2 cube so on, right? Like it can go anywhere. uh, Even just with these two variables you can get very complex graph like x6 x1 cube x power 7 x 2 cube plus x8 x1 square x2. So all these complex kind of terms like you will be able to get from this. So but what we should be doing is like all this like to get a generic formula, like generic for form of equation, what we will treat is this x1 square, let's treat it as x3. Let me write it differently. Okay, this one let's treat it as x3. Similarly, x2 square treat it as x4. This one is x5, x power 6, x power 7, x power 8. So now after doing it like this, what will be our y? So treat it as a new variable. Okay. So we again started getting something like this, right? If you see, right? So this is again same as like what we have before. So not this, like this. So then again we will be able to calculate like this, right? So and only thing is like we'll be getting theta here. So once you get theta, again resubstitute this x3 as like x1 square, x2 square, something like this, and again we will be able to do this, right? So in the same formula and with the same kind of competition, like earlier we were able to get a straight line. Now we are even able to get some kind of this kind of graph, like we are able to learn some kind of pattern like this. So if it is something like this, we are able to learn that, right? So this is one
Yeah.
very good example, like a very good feature with this kind of regression problem. It's not just limited to an order one, it can go to any order. Okay, the complexity of order you can define it like before proceeding further in the first step, like while you are defining the model structure, how complex you want it to go, and then all the required terms you can compute, or maybe there will be packages where it will be directly available anyway. But you can go to higher order complexity as well through a linear regression. Okay, so let's see one thing. Okay, let's simplify this competition. So at this level, writing like whole thing will actually won't be so easy, right? So in case if it in reality, while you are implementing it, then you being writing like keeping a for loop and adding each and every thing like would take like lot of time. So what we will try to do is introduce a concept called vectorization. So let me introduce two vector concepts called vectorization. So let's see the beauty of this concept. Okay. So let's say you have theta naught plus theta 1 x plus theta 2 x x1 plus x2 plus x3. Okay. Let me write only this. So can we write this as something like this? Theta naught, theta 1, theta 2, theta 3, 1, x1, x2, x3. If you can we write like this? See, like you have multiplication of this with this. Again, you'll be getting something like theta 1 plus theta 1, x1 plus theta 2, x2 plus theta 3, x3. Right? If you do multiplication, matrix multiplication, you'll be again getting the same thing. So, and just for simplicity, a kind of convention, instead of using 1 here, let's call it x naught. Let me call this as x naught. So then what we'll have is where x naught is 1. Okay. Let x naught equal to 1, then y equal to theta naught plus theta 1 plus theta 2 plus theta 3, and you also have x naught plus x1 plus x2 x3. Okay, right? So what we'll be having is here, let's call it a big theta. Okay, let's also call it x. You can generalize it with theta naught, theta x, where both are matrices. Okay, even the output y in this case is a single variable, so it will be a single variable, right? Because you have these things. But okay, this is what we have it till now. Okay, let's go how we are going to use it in a data. Okay, let's take the same example or any example. Okay, by randomly you can give any example. So let me give one example here. Okay, so let's take how the data is. So the data here is x1, x2, x3. Let's give values for it: 10, 20, 30, 40, 50, 60, 70, 80, 90. Just for my simplicity, I have given it like this. So what can you have it here? So y value is let me say 100, 200, 300. Let's think that way. Okay, this is the data. Uh, I wrote it like 3 points only. So let's see what you'll have. Like how can we write it in a graph over there? Okay. So you have y equal to, and here theta naught plus theta 1, assume that these are same. Okay. So next part would be, okay, so next part would be getting xy things, right? So what we thought x naught, we call it like 10, x2 20, 30, right? So if you do this multiplication, you should be getting y here. Okay, so that y actually it will be predicted here. Okay, y predicted. Okay, so this is one part, right? So in case if you let me do one thing. I'll also add other values here. Okay, let me see how we can do it. 70, 80, 90. Let's observe what will happen here. Okay, so this multiplication won't be possible because you need one more here, which is 111, right? So as x1 x naught. So let's add that part step. Let's take x naught as like 111. Okay, x naught as 111. So let's also add it into the matrix here. Okay, 111. Okay, so because x naught is 1, so now what we can do is this one, this one. Okay, how the multiplication occurs? Let's, so theta naught plus 10 theta 1 plus 20 theta 2, right, plus 30 theta 3. And similarly we also have now this way. So this is 1 into 4 row and this is 4 into 3 matrix. So you'll be getting 1 by 3 matrix finally, right? So means like one row. Okay, just a moment. Okay, let me write it like this. We'll put a transpose afterwards. So you'll be getting something like this, and this one with this, and this one with this. Actually, you'll be getting side by side. So let's put a kind of transpose at this level. Okay. So next part is actually theta naught plus what you'll be getting. You'll be getting the second column, right? 40 theta 1 plus 50 theta 2 plus 60 theta 3. So similarly, theta naught plus what you get third row, 40, 70, 80, and 90. Okay, if you remember, this is what we are going to do even here, right? We are trying to do what, like multiply theta 1, theta 2, theta 3 here, and like get first example, like we are checking with 100. And similarly, we are doing 40, 50, 60 and checking with 200, right? So this is how we are going to get. So y actual can we also write y actual as 100, 200 and 300. Okay, something like this. Can we write like this? Okay, and just a small correction to it. So like for a kind of simplicity, what we'll do is a kind of format like this. We make it slightly reverse here, where what we will be doing is we will be making theta naught, theta 1, theta 2 like this, and then x as x naught, x1, x2 like this. Okay, but anything is same, just that like the representation what you give only matters, right? So then you will be getting something like this. Okay, it's just that we are representing in a different format. Okay, let's do this. Now you want to compare these two things. Okay, like what value you are getting there and with the value you are getting here. Okay, what you are going to do, you are subtracting y actual with this data. So y actual minus theta x, you are subtracting these two. Okay, so this is the next step. So once you get this step, what are you going to do is like at this level. So after getting this, you calculate this one and then square it and then put a square root and by n, you are going to get error, right? So, and this error, the next steps are same, where we are going to find the theta naught, theta 1 and so on. But in this case, what we are doing is, in earlier case, we are calculating each at a time and then adding it and then adding it, right? Like at the level, like in the finally, we are adding those things. Now we can do all those things parallelly, just that we are uh, representing it in a matrix format. So entire calculation will happen at once. So in case we have 100 values, theta naught, theta 1, theta 2, so on, and you have this x, x naught, x1, x2, so on, if you have xn, okay? So actually, let's call it as x, bigger x, not to get confused. Okay, let me do it like this. So you have one theta here, okay, and you have first example x here, and this is example x, okay, first example one, and similarly for, let's say, data 1, data 2, data 3, so on. Okay, so for this, you can calculate for each of them, like theta x d1, theta x d2, so on, right? All these samples, like whatever data you have, it will happen at a time, like all at a time once. Okay, we can do it that way. So this is one thing. So, but actually, why this is needed is, you in our example we have only taken 3 data points, but usually it will be in like thousands or like 10,000. It may be million as well. So okay, so in such kind of scenario, calculating one at a time is not very recommended, and it would take like consume lot of time. So for that scenario, what we'll do is we will be like calculating it parallelly here. Okay, so by here, in case if you do it, let's anyway, we are going to, in further session we will be implementing this as well in Python. So then we can observe like how much time, in case if you do it one at a time and put a for loop overall, like let's observe like how much time it is going to take. And similarly, at once if you put it in a matrix representation and do this kind of vectorization and calculate those things, let's see how much time it's going to take. Okay, this is one part. Okay, so this is about it. So the next steps are clear, right? Like next thing is like doing the same way here. So let me talk about like something else, then we'll again jump to this one. So if you see, actually we call it like the transpose x, because actually like you try to represent both in theta naught, theta 1, theta 2, so on, and even x naught, x1, x1, so on, and then you call it like transpose x to actually represent. Okay, so the conventions are differently followed, but it doesn't matter like how you are going to implement. That is what is important than this. But anything is same. Like let's go follow the same convention when we are implementing it.